We have to use L'Hopital's rule to find the limit. To use L'Hopital's rule, we have to find indeterminate form. So first we have to check what will be when we replace x's by 1. So in numerator we will have natural log of 1 plus 1 minus 1 over, in denominator we will have cosine of pi times 1 plus 1. This is equal, natural log of 1 is 0. 1 minus 1 is 0, so in numerator we have 0, and in denominator we have cosine of pi is negative 1 plus 1 is 0. So we have indeterminate form 0 over 0. When we have 0 over 0 or positive infinity or negative infinity over positive infinity or negative infinity, we can use L'Hopital's rule. So it means to find the limit of our function as x approaches 1, we have to copy the limit as x approaches 1 and find the derivative of function first, which is in numerator, then derivative of function which is in denominator. Derivative of natural log of x is 1 over x. Derivative of 1 is 0. We have minus, derivative of x is 1. And in denominator we have derivative of cosine of pi of x. Let me remind you, when we have derivative of cosine of u with respect to x, this is equal negative sine of u times derivative of u with respect to x. In our case, u is equal pi over x. Derivative of u is equal pi. So we have negative sine of pi over x times pi plus derivative of 1 is 0, we don't have to write. So this is equal, let me copy this, limit as x approaches 1, and in numerator we have 1 over x minus 1. In denominator we have negative pi times sine of pi x. Now, again, first we have to check what will be when we replace x's by 1. Let me put this in brackets. We will have 1 over 1 minus 1 over negative pi times sine of pi times 1. This is equal, in numerator we have 0, in denominator we have negative pi times sine of pi is 0, so we have negative pi times 0 is 0. Again, we have indeterminate form. It means we can use again L'Hopital's rule. So we have to find the derivative of function which is in numerator over derivative of function which is in denominator. So this is equal, we have a limit as x approaches 1, and we have 1 over x. Derivative of 1 over x, we have to use quotient rule. Let me remind you, when we have u over v derivative, this is equal, in denominator we have v squared, in numerator first we have v times u prime minus v prime times u. In our case, u is equal 1, v is equal x. Derivative of u is 0, derivative of v, derivative of x, we have 1. So let me substitute now. So we will have first to have derivative of this expression 1 over x. So we will use this form. So in numerator we will have x times derivative of 1 is 0 minus derivative of x is 1 times 1 over x square minus derivative of 1 is 0, we don't have to write, and in denominator we have negative pi times sine of pi x. We have to copy, like always, the constant, and derivative of sine of pi x, we have to use formula d sine of u with respect to x is equal cosine of u times du over dx. In our case, u is equal now pi times x. So we have cosine of pi of x times derivative of pi of x is pi. This is equal. We have limit as x approaches 1 and in numerator we have x times 0 is 0, so we have negative 1 over x squared. In denominator we have negative pi times pi is negative pi squared cosine pi of x. So now first we have to check what will be when we substitute x's by 1, because x approaches 1. Let me put this in brackets. We will have negative 1 over 1 squared over negative pi squared times cosine pi times 1. So this is equal. We will have in numerator negative 1. In denominator we have negative pi squared. Cosine of pi is negative 1. So this is equal negative 1 over pi, negative pi squared times negative 1 is positive pi squared. So we can write that limit as x approaches 1 of our function is equal negative 1 over pi squared. This is my solution.